Hi guys, welcome back to another video. In this we are looking at some examples of solving problems involving finding the missing length in a right angle triangle. And of course, it is about using trigonometric ratios. Alright, so as I said in the last video, there are some questions that you need to ask yourself when attempting these problems. 1. What length were you given? 2. What length are you being asked for? And when we speak of length, we are talking about, is it the hypotenuse, is it the adjacent side, or is it the side opposite to the angle, right? So when you're answering these two questions, these are what you need to consider. What length do I have? Is it the hypotenuse? Is it the adjacent side? Is it the opposite side? What length do I want? Is it those same three things? Which one of them? Then the last question you would ask is, what or which one of the ratios use these two? Alright? So let's look. So you have to know the ratios. Sine is the opposite over the hypotenuse. Cos is the adjacent over the hypotenuse. And the tan it over the adjacent. You have in mind, so when you're answering the question, you know which one applies. So look at the triangle over here. Here is our acute angle. Remember I said you can identify the adjacent side because it has the right angle on it as well as the acute angle, the given acute angle. So if you look at this side A, here's the right angle on it, and here is also the acute angle on it. That means we want the adjacent side. And you know that the slant side is the hypotenuse, so that means you have the hypotenuse. So which one of the trig ratios, sine, cosine, or tan, uses A and H, uses adjacent and hypotenuse? Cos. So that means we would be using cos ratio to solve the problem. So the first thing you do is to write the formula. Cos theta equals adjacent over hypotenuse. And then you substitute the values correctly. Alright? So remember, theta represents the angle. So we're going to have cos 56 equals A is adjacent and the hypotenuse is 13. And then you can cross multiply, or you can do what we did before. If you're moving a term or something, an expression from one side of the equal sign to the other side, you do the opposite. So we want A alone, so we would move the 13, and seeing that we're dividing by 13 over here, we would end up multiplying by 13. So we would say A is equal to 13 times cos 56. And you would put that in a calculator and get the answer. So I'm rounding the answer to one decimal place. So A is equal to 7.3. Originally it was 7.26, rounding to one decimal place. The number after the 2 is 5 or more, so we add 1, so 7.3, and that is our answer. Let us look at another example. Alright, so let's look at example 2. Again, you ask yourself the question, what do I have? What length was I given? What length am I being asked for? So we know that we can always draw an arrow to the other side for opposite, so we have the opposite. And the slant side is generally the hypotenuse. In this case, it definitely is. So we want B, which is the hypotenuse. Which one of the ratios use hypotenuse and opposite? Sine. So we write our formula, sine theta equals opposite over hypotenuse. Remember, theta represents the angle, so sine 35 equal opposite, which is 6 over hypotenuse, and the hypotenuse is B. Again, you can cross multiply, or you can move. And when it involves a fraction, you always have to, whether it's unknown or known, you always have to actually get rid of that fraction that involves the unknown. So if we have divide by b, so when we move b to the other side, we'll multiply. So now we will have b times sine 35 equals 6. We want b, so now we need to move the sine 35 to the other side, and we were multiplying, so now we're going to divide. So b is equal to 6 divided by sine 35. Put that in your calculator and you've got the answer. 6 divided by sine 35 is 10.46. Round that to one decimal place, it's going to be 10.5 centimeters. I hope this video helped. If you feel like you need another example, another video, let me know. Remember to like, share, subscribe if you have not done so. Bye guys.